Hello guys, we are here in Earl Kitchener Elementary School in Hamilton, Ontario, Canada. In here we changed the heating and we added a new cooling system. So when we did the heating system, we added 2 new boilers and we ran new piping throughout the entire building, and then we added new individual units into each classroom. But what's interesting is this school, probably hundreds of years old, never had air conditioning. So what we did is we put this big unit up on the roof, we put it on our back and we started climbing. No, I'm just kidding. We did it through a crane, which we'll show you the crane video. But before we show you the crane video, I want to take you inside the boiler room, which is the mechanical room, which is like the heart of this entire building. So let's go inside and we'll show you more. Hello, so we're in the heart of the heating and cooling system. So how we initially started was we did a complete demo. So once everything was done, it was just a room in here. So what we first did is we brought these 2 boilers in. We brought it through this opening, we brought it in, we put the units in. So when you do something like this, you have to first put the units first. So we did the boilers first. This is the heat exchanger. We put that, those were the heavy equipment. And from there, we started doing the piping network. As you can see, these are the pumps. These run hot water to the entire building of the school, and also sends up onto the cooling tower, which we'll go up and see in a second. Okay, so the reason why we have 2 boilers is one is usually for backup, and the other one is all operational. So especially with when you have maintenance, when you have mechanical equipment, they break down. So in terms when you get parts, sometimes we might not be able to get the right parts at the right time in the time that we need. So that's why you always have a backup. It's more for a backup system rather than for demand, because sometimes when it goes to a certain temperature, both boilers will kick on, but it's rare that you need both. It's more for the reliability of the whole design of the system. So when engineers design the whole thing, that's why you have 2 pumps and you have 2 boilers in case something breaks down, there's a mechanical breakdown, whatever it is, they always account for that design parameters when thinking about the design of the boiler room. So here, when we first put the boiler, we put the boilers in and then we did the venting outside. Venting is a flue gas that gets combusted and goes through the chimney. So we'll take a shot upstairs and we'll show you how far this chimney goes, and it goes all the way to the roof and actually 6 or 7 feet above the roof itself. Back of the boilers, one of the greatest challenges that we had here was running the venting, because as you can see, the venting both come into one chimney and they go all the way to the roof. So we had to do a lot of work with the guys. They were working tirelessly to make sure that we got this venting properly, with the proper slope, with the proper drainages, to make sure the boiler is going to work at its best capacity. What we have here, guys, is called a plate heat exchanger. This was a vital component in order for us to introduce air conditioning into this building. So what we have here is we have these 2 lines that are going into the cooling tower with glycol, and these two lines are going into the building itself. The nice thing about the plate heat exchanger is you never have any mixing of the water. All you have is thermal energy transfer only. So that's the nice thing about the heat exchanger. And again, it's called a plate heat exchanger. Here we have all the pumping assemblies. So when we did the pumping assembly, we had to make sure that we positioned the pumps in a certain way so that all the piping network had to make sure that they didn't collide. So initially we had a CAD drawing done on this, a 3D drawing, before we put any of the equipment on the ground. Just to tell you a little bit about the pumping assembly, so we've positioned this in a way that these two pumps provide the secondary heat exchanger for the heat pumps that are in each classroom. So these work in the secondary side of the building to work heating and cooling. So these pumps work during heating season and also in the summer season. So these are heating hot water. These go to your rads and all the ones that are in your hallways. So these only work in the summer, winter time, because they only provide the necessary heating that the entire building needs. Over here, we have these two pumps work in a way that it brings water from here all the way to the cooling tower. So these pump through these two lines and all the way outside along the building all the way to the cooling tower. So when we go see the cooling tower, I'll show you where these piping assemblies join. So one of the important things about this is more like your antifreeze. This is going into the cooling tower to make sure the pipes they don't freeze during the winter season. So we always need to make sure that this is at a certain level and make sure it always circulates in the system. Okay, so what we have here is what's called a heat pump. So we had 40 of them or so in each classroom. And the nice thing about these heat pumps is that these work with both in heating mode and in cooling mode. So this works very similar to like your condo unit. If you guys have seen, you got to wait for your building to change over to certain seasons. So this works in a very similar way. This rejects all the heat. They have two pipe systems at the back, and it either rejects heat or extracts heat from those piping. So that's kind of how this heat pump works. It has its own heat compressor, and it has its own core. So this works like a small air conditioning system, but the secondary side of it, it's water cooled, and this is what we have in each classroom. Welcome to the roof. So as you can see behind me, we have multiple units. We're going to go through and we're going to explain each of them to you. So this is the ductwork that we initially started with. As you can see, this is the return. This brings the air from the building and it goes to the unit, heats it up or cools it with a heat exchanger in the unit, and it pushes into all the corridors. And this doesn't provide any heating to the classrooms, but it only provides to the corridors and the hallways. So as you can see, we've insulated this. How we were able to get this nice edge is we used the drywall beads. If you guys seen it, it's the aluminum drywall. We put it on the side, the beading, and we put the insulation, and then we wrap it on what's called an aluminum jacketing. This is used for weatherproofing, just to make sure during our Canadian seasons, especially summer and the winter, everything contracts and expands, contracts and expands. So you want to have something that's very reliable. So that's why they always recommend that you have a jacketing, aluminum jacketing on top of the insulation. So here, this was a very difficult turn, but our foreman was very skilled in getting that turn and making sure we installed it. Because when we run the ductwork, we put the units first, and then we run any of the necessary ducting. So that's why we had to put the unit on there first and then start doing the work underneath. And the duct was a really, as you can see, this is close to 6 feet in width. So we had to make sure that we got connected everything inside. This structure was done by our general contractor. Once the structure was done, we put the unit up on the roof. So as I mentioned, this provides heating and cooling into the corridors, right? So this section, as you can see, this is natural gas or methane that comes in. It uses in the fueling system, and it exhausts the venting, right? So this heat exchangers, in this unit, there's a heat exchanger that catches the heat air and the building air, but they don't mix together. All they do is they transfer thermal energy, and they pass the thermal energy to the incoming conditioned air and throws it into the building. So this is the back of the DOAS system, the DOAS system. This is a Daikin unit. These are the compressors. As you can see, all the cylindrical units are the compressors. This kicks on during the summer season. As you can see, it's cold out, so it's in sleep mode. But sometimes if sometimes our weathers can go to +10 in winter times, so sometimes if that's needed, this will kick on. That is all operated through what's known as a BAS system, building automation system. Okay, so we are here in the cooling tower. So this was a very vital equipment in order for us to introduce air conditioning into this building. So as you can see, those pipes onto my right, they're brought up from the boiler room all the way up here. And what the cooling tower does is it rejects all the heating. In the summer season, what the cooling tower does is it rejects all the heat within the building into the atmosphere. What you see in the cooling tower is 2 fans, and it does a heat exchanger within the 2 systems, with the 2 piping systems, and it rejects the heat. On this side, we have the controls and the high voltage. This runs on a 600 volt 3-phase, so we had to get electricians to make sure that it was done right. This is controls and the high voltage. And the structure was done by our GC. Before we put, this is a brand new structure that was introduced to house the cooling tower. And what they had to do was they had to reinforce the entire structure all the way to the basement. In the boiler room, they had to reinforce to have this weight on top of the roof, because especially with so much water running through the system, you have to make sure that it's structurally sound to put on the roof. Over here in the boiler room, we showed a glycol supply and a return. Again, glycol is used as antifreeze just to make sure during the winter time that these pipes aren't going to freeze. So there's water in there right now, but because of the glycol, we don't have to worry about it expanding, freezing and expanding the pipes. So this is a closed system. It goes to the top, and you have an open system where you have water trickle down, and it does the whole heat exchanger there. So these are there's chemical supply and return. You have to make sure that we maintain a certain pH level and it's clean inside the unit, because better clean it is, the less maintenance it is for these units. And as you can see, these are the pipes. They go all the way into the boiler room. These pipes are insulated. These are regular black iron, just regular black piping. We can't just have them as is. That's why these are all insulated and protected, weatherproof, so you don't see the actual black piping. But underneath, when you go down, it's pipes that you can weld together to make sure that they're structurally sound. Alright guys, that's all we have for you here today, you guys. So I just want to take the time out to really thank my team. We were able to finish the project during COVID while everybody decided to stay home. You guys decided to wake up and crush it, and we were able to deliver. So I appreciate you guys. And for those of you who are watching, if you liked the video and if you found some value in it, like the video, subscribe, and share with your friends. Until the next video, keep being awesome, and we'll see you on the next one.